Hey guys, Chapter 5, Section 4 video here for you. If you're using the same textbook as we are in class. And here's the essential question. What types of systems can I solve? So we're kind of down to the end of this chapter. We're kind of wrapping up what we know about systems. And one of the things we've been learning is how to solve a system without having to graph. So for our notes today, we're going to write down those 3 methods of solving. And I would challenge you to hit the pause button right now, and can you list out the 3 methods? Do you know them? Well, here they are. I'm going to go through them. Method number 1 is what I call the equal values method. Equal values method. It's when you have 2 equations that are both in that nice y equals mx plus b form. And then the second method we've been working really hard on is the substitution method, which is the one I always nickname the bubble method. Substitution is when you have one variable isolated all by itself, but maybe the other equation not so much. And then we've got this newest method, which is called the elimination method, and that's where everything lines up and you use kind of like your elementary school adding and subtracting skills to solve. And your job at this point is you need to know which method to pick. What's the best method for this situation? Because truthfully, like in a real life situation, no one comes up to you and says, "Can you solve this and will you use the elimination method, please?" Like, nobody does that. So you got to be able to pick the method and choose the right one. So I'm going to give you a problem here, our first example, and we're going to solve this system. I want to know where negative 2x plus y equals 9 intersects on a graph with x plus y equals 12. I want to solve for x and y. But first, I want to know what's the best method. So what do you think? What method would you choose if you saw this like on a test and you had to choose all by yourself? What would you do? Oh, I really hope you're saying elimination. It totally looks like elimination. Everything's lined up vertically really nicely. The x's, the y's, the numbers. So we're going to put a line under that and solve. I do see one little problem. The y's. They're both plus y. Nothing's going to currently eliminate. What I really want it to be is minus y. I want it to subtract. So I'm going to change the sign to subtraction, but I also have to change all the signs. So I'm going to make it a negative x, a negative y, and a negative 12. And then I'm ready to solve. Now the y's are going to eliminate now that I got those negatives. So let's get rid of the y's. Cross those out. They're gone. Let's take the negative 2x and the negative x and combine it to negative 3x. And 9 minus 12 is also a negative 3. So negative 3x equals negative 3. Well, we'll just divide that negative 3 away, and we'll be ready to get our solution here. 3 divided by 3 is 1, and a negative divided by a negative is a positive. So we get x equals 1, and there's our solution. But we do need to solve for y. We have to have both answers. So let's go back and let's pick one of the equations. You choose which one you want, the first or the second. I'm choosing the first one. Negative 2x plus y equals 9. I'm going to copy it back down on my paper. And now that I have an answer for x, I'm going to replace the x with 1. So it's going to be negative 2 times 1 plus y equals 9. All right, let's do some math here. Negative 2 times 1, well, that's negative 2 plus y equals 9. Let's just add the 2 over and we'll have our solution. Y is going to equal 9 plus 2. 9 plus 2 is 11. There is our other answer. So now we know if I was to make a graph and graph these lines, they're going to cross at 1 and 11. That's the x and the y coordinate, and that is our solution. All right, let's look at another example. Example 2. This time we're going to solve this system. Y minus 3x equals negative 4, and negative 2y plus 4x equals negative 4. Most importantly, what method will you choose? Does it look like equal values? Does it look like bubble method? Or does it look like another elimination problem? What do you think? I think it's elimination again. It looks like everything's lined up perfectly. Again, the y's and the x's and the numbers. Only situation here is if you look at them, nothing is matching up. Like the y's, it's y and negative 2y. That doesn't match up. And 3x and 4x don't match up. So nothing actually eliminates. So we got to fix it. So here's my strategy. I'm going to take that top equation and I'm going to times everything by 2. I'm going to do 2 times y, 2 times 3x, 2 times negative 4. And I'm going to draw a little arrow and I'm going to rewrite the problem. The new equation is going to be 2 times y, so 2y, minus 2 times 3, so 6x, and 2 times negative 4 is negative 8. The second equation, I'm not going to change. I'm going to keep it the exact same. Negative 2y plus 4x equals negative 4. But look what happens. The y's are ready to eliminate. 2y and negative 2y is a perfect setup. We can get rid of them. They can eliminate. So if those go away, then negative 6 plus 4 makes a negative 2x. And negative 8 and negative 4 make negative 12. All right, we're really close to an answer. We're going to divide the negative 2 away, and we're going to get x equals 6. 12 divided by 2 is 6. So there's our solution, but we got to solve for y, so don't forget to solve for y. I'm going to go back and copy one of the equations. I'm choosing to copy y minus 3x equals negative 4. We think the answer is x equals 6, so we're going to be putting a 6 in there. We're going to make it y minus 3 times 6 equals negative 4. And then we're going to do our math here. So let's see, 3 times 6 is 18. So y minus 18 equals negative 4. Let's add the 18 over. If we add it to the other side, 18 plus a negative 4 is 14. So y is equal to 14. So if I was to graph this graph, the lines cross at 6, 14. There's our coordinate points on the graph. That's our point of intersect. All right, guys. So it is now your job to start picking the right method. You have to know, does it look like elimination, substitution, or equal values? And to wrap up this video, I just want to point out a couple things about the elimination method. Do not forget, when things line up, sometimes you have to change the signs. Maybe make them all negative or switch to positives to make something eliminate. You also sometimes have to multiply the entire equation, like the last example where we did times 2 times 2 times 2. Sometimes you have to force the equation to match up with the other one to get something to eliminate, because it only works if a variable eliminates. So just keep that in mind as a strategy. Thanks for watching, guys. I will definitely see you in class, and have a good day.